Hey guys, we're gonna start the 1.1 notes for Algebra 2. It is key features of functions. So this whole kind of first unit is gonna be sort of reviewish of certain things from Algebra 1, Algebra 2, but taken to another level. Okay, so you should be familiar with some of the language that we use. So this first thing is just kind of a warm-up. This is easier when we do it in class together, but I'll kind of run through these questions just to kind of get you guys used to graphing and remember some old things. So it says, what details can you determine about the dive from the coordinates of 0.5, -8? So we look at 5, -8 is right here, right? And some things we might be able to decipher from this is, right, it's at 5 seconds. Okay, so it's at 5 seconds, right? And our depth is feet in feet, so we're at 8 feet below the water level. Right, and this would be, as we can see, this 5, -8 would be our lowest point. Right, lowest point of the graph. Now it says, what is the average speed of the diver in the water? How can you tell from the graph? Well, right, our average speed, we'd be looking at the slope of it. Okay. Now to find the slope, we can pick 2 points. So if we pick right here and a point here, now we're going up 1, 2, right, and then to the right, technically 1, because it the increments are by the boxes are like a half. Okay, so if it's up 2 to the right 1, we know our slope is 2/1 or 2. Now that tells us that the average speed is 2 feet per second, right? Because we have feet over seconds. All right, so that would be our average speed. Okay, speed, we can't have negative, so right, we could tell this would be technically a negative slope of 2/1, but because we're talking about speed has to be positive. Now, which point on the graph shows the starting location of the diver? Okay, so where did he first dive from? Well, that'd be the beginning of the graph right here, which is at 0, 2. So our point is 0, 2 as the starting location of the diver, right? And this is the point at 0 seconds, okay? Right, because at 0 seconds is when he started the dive. And last it says, what does the V shape of the graph tell you about the dive? What information does it not tell you about the dive? Okay, so one thing it tells us, right, is he dove down and then went back up. And then one thing it doesn't tell us, so it doesn't tell us really if he went horizontal or not, right? If he went right to left, you can't really tell. You can only tell that he went down or up, okay? So it doesn't tell left or right, meaning if he dove horizontal or not, like sideways. All right, so that was just kind of a warm-up to get us used to looking at graphs. So now we're going to move on to the first example. The first example deals with domain and range. So the first thing we want to do is give a definition of domain and range. So our domain, if you can remember, is the set of all inputs. Now, inputs are the possible x values. Right, so any x value on the graph represents the domain. The range, right, is the set of all outputs. And you probably guess or remember it's all possible y values in the graph. Okay, so any y value you can see on the graph. Okay, so right, let's first find our domain. So our domain, right, it's any x value. So you're looking for what x values can be on this graph. Well, if you think about the graph, it's going to keep going this way. So it's going to keep going all the way to the right and then all the way to the left. Okay, so if it's going to go all the way to the left, that means it's going to negative infinity, right? So this is going to keep going all the way to negative infinity on the x axis. And this is going to keep going to infinity because it's going to the right. It's going to continue on forever. Now, when you have something that goes all the way to negative infinity and all the way to infinity, you should remember, hopefully, that it's going to be all real numbers. Okay. And now we can represent these in two different ways. Right? We can use interval form, and we can also use set builder. Now, interval form will have parentheses or brackets, depending on if it stops or not. Okay. For infinity and negative infinity, you always have just parentheses. But if it's a clear stop and it includes a number, right, we use a bracket. Okay. So for intervals, right, it goes from negative infinity all the way to infinity. So that's how we write all real numbers for interval form. Now set builder, right, set builder, because we're finding the domain, right, it's the set of all x's, right, or inputs. Then we make a line, and then for set builder, we use inequalities. So it goes from negative infinity, right, and x is greater than negative infinity, but less than infinity. All right. So throughout this 1.1, if it asks you to use interval, you're going to use this. If it asks you to use set builder, you're going to use this. Okay. Now, we're going to have to go through the range. Okay. All right, we know our range is the set of all outputs, so the possible y outputs. So when we look at this, right, as our function, right, it goes up. Okay, so it continues to infinity for the y values. Now, we can see that it stops at a certain point here. Okay, it does not continue all the way down to negative infinity on the y-axis. So if it stops at this point, right, we need to figure out what point this is. This says 0, -3. Right, so that means, right, our function, right, goes all the way to infinity, but our function stops at -3 as our lowest point. Okay, so our lowest point is at y equals -3, okay? And then it goes to infinity, right? It goes up to infinity. Okay, so because our lowest point is at y equals -3, right? This tells us that our range is all real numbers greater than or equal to -3. Okay, so it starts at -3 right here, and it goes all the way up to infinity. Right, so it includes it. That's where you have greater than or equal to -3. Right, now we have to write this in interval and set builder notation. So interval, right? I said before, if it's greater than or equal to, right, it includes -3, we use a bracket at -3. Now, anything for infinity or negative infinity, we use a parentheses. If it was just greater than -3, we'd have a parentheses to start. Then the set builder, finding the set of all y values, right? It starts at -3, is less than or equal to our y, which is less than infinity. Okay, so remember a few things, right? Is the brackets if it's greater than or equal to, or less than or equal to. All right, now we're going to look at a real world type of an example of finding the domain and range. Okay, so first we need to figure out what our function is. So our function and we represent functions with f of x or g of x, or something like that. Okay, we're going to name it f of x. Now our function is equal to, right, our 400 gallons per second times the number of seconds x. Okay, right here it says x seconds, right, and it's our constant rate is 400 gallons per second, as you can see from the picture right here. Right, and our start off is that we have 8,000 gallons. Right, so what we want to do is find out when our tank is empty, and that's why our function is our 400 gallons per second times the number of seconds. All right, so let's try and find our domain first. Okay, now our domain is represented by x seconds. Okay, so can you have any negative seconds? No, you can't. Okay, so our domain has to be at least x is greater than 0, right? Because you cannot have negative amount of seconds. Right? We can't have negative time. Now, we want to find the max. Okay, so this is our minimum amount of seconds. Now we want to find our max amount of seconds. Okay, well, we know there's 8,000 gallons, right? And we lose 400 gallons per second, right? So we're going to represent this as 8,000 gallons divided by our gallons per second, all right? So the max amount of water, the max amount of seconds we'll have is 20 seconds, right? Because 8,000 divided by 400 is 20 seconds. So our x needs to be less than or equal to 20. Now, what does this tell us about our domain? Well, our domain is the set of all x values, right? So it says our lowest point is 0, and it's greater than or equal to 0, so we have a bracket. And our max for x values is less than or equal to 20, so it's going to be 20 with a bracket. Okay, and then if we want to write this in set builder, right, we have x line 0 is less than or equal to x, which is less than or equal to 20. All right, now next we have to find our range. Okay, so this is going to be pretty easy, right? Our range is represented, so it says the volume of water is our range. So, right, the amount we can lose, right? So the minimum amount of water lost, okay, is 0, right? 0 gallons, right? You could lose none. And the max amount of water lost would be 8,000. Okay, so, right, y can be greater than or equal to 0, and y can be less than or equal to 8,000. And this is our range. So we want to find our range. Now, this is greater than or equal to 0, so bracket 0, comma, our max is 8,000, so bracket, 8,000 bracket. And then our set builder, the set of all y's, right, would be 0 less than or equal to y, which is less than or equal to 8,000. All right, the next topic to review is x and y intercepts. Okay, so our x-intercept, right, is where our function crosses that x-axis. Well, when it crosses the x-axis, that means, what's that, x-intercept? Right, when it crosses that x-axis, that means it's when y equals 0. Okay, and then our y-intercept, meaning when it crosses our y-axis, that's when x equals 0. All right, so again, you should have done this before, but just to remind us, right? So to find the x-intercept when y equals 0, we're going to take this function and we're going to substitute in 0 for y to find our x-intercept. Okay, and we're going to solve for x. Vice versa, for our y-intercept, we're going to substitute in 0 for x, and then we're going to solve for y. Okay, so right, I'm going to substitute in 0. So first I'll write our function y equals the absolute value of x minus 3. I'm going to substitute 0 in for y and then solve for x. So I'm going to add 3 to the other side. The absolute value of x equals 3, right? And now, remember, absolute value tells us that there's two possible answers. X can either be positive or negative and still get a result of positive 3. Therefore, x is either equal to positive 3 or negative 3. Because if you take the absolute value of 3 here, you get 3. And the absolute value of negative 3 is also 3. So we have two answers. That means there's two x-intercepts. That means our function is hitting our x-axis at 3 and negative 3. Okay. All right. So next is to find our y-intercept. So we're going to substitute 0 in for x into our function. So y equals absolute value of x minus 3. I'm going to substitute in 0 So y is equal to -3. That means we're crossing our y-axis at -3 with this function. Okay, and this is our y-intercept. So now what I'm going to have you do is try on your own. So please pause this, and then I'll write the solutions in for the try it on your own, and you can review your answers. Okay, so hopefully you pause it and you try this on your own. I'm going to quickly go through the solution for the try it on your own here. Now for our x-intercept, right, I'm going to substitute in 0 for y. Okay, so this is technically our y, our g of x. So I'm going to put 0 in. 0 is equal to 4 minus x squared. Subtract 4, get -x squared. And then I divide each side by -1 to get 4 equals x squared. And then to solve for x, right, we take the square root, because the square root of x squared is x. Now, one thing to remember about the square root, hopefully you remember, is you get two answers. Right? It's plus or minus whatever answer you get. Okay, so the square root of 4 is 2. Square root of x squared is x, but we get plus or minus 2. Okay. Or x equals 2 and x equals -2. Okay, so with absolute value, we get two solutions. With square root of a number, we get two solutions. The y-intercept, we're going to substitute 0 in for x, so y equals 4 minus 0 squared. So y equals 4, very easy. And there is our y-intercept. All right, the next part of this section is identify positive and negative intervals. Okay, so positive would be above the x-axis. So positive is above x-axis. Negative below x-axis. And neither means it's on the x-axis. So that'd be our x-intercepts. Okay. Now, what we can do is just put this into interval notation. So we're going to represent the positives above the x-axis. So right here, see how it's above it? Okay, anything above this x-axis. So you can see there's going to be two parts to the positive. Our negative I'll represent with red. So it's this part below the x-axis. So technically a negative y value. Any negative y values. Positive would be any positive y values. And then the neither where it'd be when y equals 0. So neither would be this point and this point. All right, so let's write them in. So this one starts at -infinity and stops at -3. So our first one is -infinity. And then, right, we're not including -3 because that point is neither. That's where y equals 0. So we're going to have another parentheses. Now we have another interval where it's also positive, starting at 3, going to infinity. Where is it negative? Well, starting at -3 right here, and then all the way to +3. So -3, +3. Okay, and then last is neither. So that's the x-intercept. So this is at -3 and +3. So x equals -3, +3. All right, so what I'll do is I'll kind of just give you a short spiel on each of these to help you remember. So positive, where I'm going to use f of x to represent function. So where f of x is above the x-axis. So any positive y value. Negative is where f of x is below the x-axis. So any negative y value. Okay, and as you can see, we're only representing the x values for our solutions. So our positive interval is the x values. Our negative interval is the x values, and neither is also x values. And then neither, right, is just our x-intercepts. And that's where y equals 0. Okay, so what I'll have you do is try the next two on your own. Okay. So you're going to try these on your own. So I'll have you pause it. Sorry, not next two. It's technically the same question. So you're going to have to graph 2x plus 10. Hopefully you know how to graph that. All right, this is your slope. This is your y-intercept. Okay, if you really have trouble graphing that, put it in Desmos and then try it and tell me where the positive and where the negative value intervals are for the function. All right, so here's our solution, right? You're figuring out where the function is negative, so it's below, right? This is where it's negative. It's below that x-axis from negative infinity to that point -5. And then it is positive from this -5 all the way to infinity. Okay. And if, I didn't ask you for neither, but obviously neither would be where the x-intercept is. So x equals -5. All right. The next one is increasing and decreasing, as well as max and min. Now, increasing and decreasing gets mixed up with positive and negative a lot, so please pay attention to the differences. I'm going to go through the definitions first. Okay, so if it's increasing, that means our slope is positive. Okay, so it means our slope is going up, okay, up and to the right. Now, if it's decreasing, that means our slope is negative. Okay, so you got to look at the behavior of the function. Okay. The next is max, right? So our max would be, right, our highest y value. Okay, so as high as the function goes, and our min would be the lowest y value. Now, some functions only have a max, some only have a min, some have both. Okay, you'll see examples of both of these. And then some don't even have a max or min at all. That'd be a linear function. All right. So now let's go into solving this and looking at this. So we're looking at the function 2 minus absolute value of x. The picture's right here. Okay. So where you want to find where it's increasing, we want to find where the slope is positive. Okay. So we kind of have absolute value looks like two linear functions put together. So we can tell this slope is going up and to the right and it's positive. okay? Because our slope is positive from here to here, right, and stops at this point, right, that means it's increasing. All right, now we need to find the interval of it. Well, this has an arrow going all the way to negative infinity. And then this point right here is 0, 2. Okay, so our interval is going to go from negative infinity and then stop at 2, but not include 2. Okay, because at 0, 2, there's not a positive or negative slope. Okay, so we're going to write for increasing. It starts at negative infinity and continues to the point 0, 2. And that x value that it stops at would be 0. All right, so it stops at x equals 0. Now, for decreasing, we're going to look at where the slope is negative. So we can see it goes here is negative slope, and it's going all the way to positive infinity for an x value. Okay, so that's where it's going to stop. But it starts at where x equals 0. Okay, so our decreasing is 0 to positive infinity. Okay. Make sure you're using x values to represent increasing and decreasing. Okay. Now for our max and min. Let's look at our min. Well, as we can see, the graph is going down and down, right? So that means it's going to keep going down to negative infinity. So technically, we don't have a minimum value that we can represent for this graph. It has no minimum. But we can find a maximum, right? Remember, max is the highest y value. Okay, so we're giving y values for the max and min. So don't get confused with increasing and decreasing and positive and negative. They use the x values for intervals. For max and min, we're going to tell the highest and lowest y value. So our highest value we can see on this is at y equals 2, right? That's the highest y value in this function. So we're going to write y equals 2. In minimum, we said it goes all the way down to negative infinity. So technically, we have no minimum, or there's none. All right, so what I'm going to have you do is now go to the next part where it says try on your own, and I'm going to have you try this on your own. So what you'll have to do is graph this function. Right, again, it's a linear function with a slope of negative 2 and a y-intercept of negative 3. Okay, so if you have trouble graphing linears, hopefully not, but if you do, you can use a Desmos or something like that to help you graph this. And then I want you to find whether this asks for where is it increasing and where is it decreasing. Okay, it doesn't ask for max or min. So please pause this as you try this on your own, and then I'll give you guys the solution. All right, here's the solution. As you can see, it's a linear function, so it's either going to be increasing or decreasing because it has a constant slope throughout the whole function. Our slope is negative, right here. So you should know it is going to be a decreasing linear function. And where is it decreasing? Well, it's going all the way to negative infinity on our x values and all the way to positive infinity. Therefore, it's decreasing from negative infinity to positive infinity. Also, we have no max or min because there is no maximum point we have and no minimum point we have. All right, now the last part of 1.1 is finding the average rate of change. Okay, so it says, what is the average rate of change of a function y equals f of x over the interval a, b? Okay, so we're looking at a to b, and we're looking at the change of this function from a to b. So from here to here. Well, how do we find this? Okay, so this point right here, A, and this point here, B, okay? A is on our x-axis, so we write A, and then, right, our y value is f of A, meaning if we substituted in A, right, into our f of x, right, we'd get f of A, okay? And that's our y value. Same thing for B. This is B, and then f of B, right? Because you're substituting in, instead of x being our x value, we represent it as B, so it's going to be f of B. All right, now our formula to find the average rate of change. So average rate of change, what we do is our function y equals f of x over the interval AB. All right, so it's going to be f of B. So our y value when we substitute in B into the function minus the y value when we substitute in A to the function. And then it is over our B minus A. Okay. So again, this is our y values. This is our x values. Okay, so the average rate of change is the slope from two interval ends. So technically is the slope. Okay, so the average rate of change would be this kind of line that we're trying to find. So we'll get technically like the slope from A to B, even though we know the function, it makes like this curve shape. Okay, so this is our average rate of change. Right, and that's our slope of our function for interval A to B. All right, so that's kind of the formal definition. What we'll do is go through an example together to help you guys out. All right, now to solve this problem, all right, it says, what did the average rate of change over the intervals -2 to 0, 0 to 3, and -2 to 3 indicate about the given functions? Okay, so we're looking at three different functions. F of x equals 1, g of x equals 1/2 x minus 1, and h of x equals x squared. Okay, now what I'm going to do is kind of make a table to finish this problem. So I'm going to represent the first column as our three intervals, right, that were given in the problem. Then I'm going to solve for my f of x equals 1. My g of x equals 1/2 x minus 1. And my h of x equals x squared. Okay, and then the intervals we're looking at is the average rate of change from -2 to 0, from 0 to 3, and from -2 to 3. All right, so remember our average rate of change is equal to f of b. So the y value when you substitute b in minus the y value when you substitute a in. Okay, all over b minus a. Right, so in our first one, this is our a, this is our b. So if we look at this function here, if we substitute -2 in for x, right, we can see there is no x in the function. Okay, so technically our y value. So if we substitute in -2 or 0 or anything, our y value is just going to be 1. Okay, because it's saying f of x equals 1 or y equals 1. And you can kind of see by the graph too. It stays on y equals 1. All right, so we're going to have 1 for if we substitute in 0 for x minus, right, f of a, right, substitute -2, you still get 1. Right, and that's all over b, which is 0, minus a, so minus -2. Right, you still get 1 minus 1 is 0, over 0 minus -2 is 2, so 0 over 2 is equal to 0. So that's our average rate of change from -2 to 0. All right, let's try from 0 to 3. Okay, again, our function, whether we substitute in 0 or 3, our y values are always going to be 1 because there's no x in the function. And then we have 3 minus 0, so you get 0 over 3. And then again, we get 0. And this should happen every time. As you know, it's going to be 1 minus 1 over 3 minus -2. So 0 over 5. And that is also 0. All right. Let's do it for g of x now. So g of x, right, now we're substituting in, right, for x, okay? First is our b value, right? So we get 1/2 times 0 minus 1, right? And that's our f of b. Let me write this a little nicer. So, right, g of b technically is 1/2 times 0 minus 1, which is just -1. Find g of a is 1/2, and then substitute in -2 minus 1. So -2 times 1/2 is -1, minus 1 is -2. Now we're going to use the average rate of change formula, right? So g of b is -1 minus g of a, -2, all over b, which is 0, minus a, which is -2. So -1 minus -2 is going to give you 1. And then 0 minus -2 is going to give you 2. So our average rate of change is 1/2. Do this for the next one. G of b is 1/2 times 3, because 3 is our b now, minus 1. So 3/2, right? 3/2 minus 1. Whoops, sorry. 3/2 minus, there we go. You get 3/2 minus 1, which would be 1/2. All right. And then we have g of a, which is 1/2 times 0 minus 1, which is -1. Okay. So we're going to do g of b, so 1/2 minus 1 over, minus -1 over our b, which is 3, minus 0. So then we get 1 and 1/2 over 3. Right, and 1 and 1/2 over 3 reduces to 1/2. Right. Or 1.5 over 3 is also 1/2. Right. The next one is g of b equals 1/2. And then our b again is 3. And then minus 1. So we get 1/2. Then g of a equals 1/2 times -2 minus 1. -2 times 1/2 is going to be -1. Minus 1 is -2. So we get g of b, so 1/2 minus 2. Oh, sorry, minus -2. So make sure you don't forget to minus the negative over the button's in the way. I gotta write it over here. So 1/2 minus 2 over b, which is 3 minus -2, which gives us 2.5 over 5, which also reduces to 1/2. All right, and then the last one, this one might be a little easier because there's less halves. Okay, I'm going to skip writing g of b and g of a, right? Just substitute in for x, okay? Or, sorry, this would be h of b and h of a. Okay, so if I substitute in b for x squared, 0 squared is 0. So g of b, oh, I told you I wasn't going to write it out. So g of b is 0 minus g of a. So -2 squared would be 4. And then over b, which is 0 minus -2. So you get -4 over 2, which is -2. That's our slope. And that's our average rate of change as well. Now, b is 3. So 3 squared gives us 9 minus, substitute 0 in, 0 squared is 0, over b, which is 3, minus a, which is 0. 9 over 3 equals 3. So our average rate of change is 3. Okay, and then last one, 3 squared again is 9. -2 squared is 4 over b, which is 3, minus -2. So we get 5 over 5, which is 1. All right. Last part, it says indicate about the given functions. So what does it indicate? Well, f of x, right? We have a constant rate of change, which equals 0. Right? All three of them are 0. 1, 2, 3. G of x, we also have a constant rate of change. Right? Constant meaning it does not change at all, whether it's this interval or this interval or this interval. Constant rate of change, which is equal to 1/2, right? Because they're all 1/2. And then the last one, right? H of x, we do not have a constant rate of change, so the rate of change, the rate changes. Okay, we don't have a constant rate of change. Right, 1 is -2, 1 is 3, and 1 is 1. So the intervals change the rate of change. All right, and that's it for 1.1. I know it's a lot. That's why I gave you multiple days to do this. Please, if you have any questions, let me know through Remind or Google Classroom, and I can help you out with this. Also, there are attached videos, helpful videos for this. So make sure you use those videos. I kind of link them to each example. One for example 1, example 2, example 3, example 4, and example 5. So those YouTube videos will help you get through the questions as well.